In this lesson, we are just going to look at the key ideas that we learned from the previous activity. So if you did the previous activity, you learned something important, and I'm just going to summarize what that is and give you a few other formulas that will come up later on in this particular section. The investigation was how does scale factor affect two things? How does scale factor affect surface area, and how does scale factor affect volume? And here's the relationship. If a three-dimensional object is enlarged or reduced by a scale factor, and we're going to call the scale factor the letter K, then the surface area of the new 3D object is K squared of the original shape. Or in other words, this may be helpful to write down as well, the original surface area times the scale factor squared is equal to the new surface area. Okay, so that's the relationship between scale factor and surface area. The second thing that we learned in the previous activity was if a three-dimensional object is enlarged or reduced by a scale factor, and we're again going to call it K. So if the measurements are enlarged or reduced by a scale factor of K, then the volume of the new 3D object is K cubed of the original shape. Or in other words, you may want to write this down. This is going to be the most useful formula for it, is that an original volume times a scale factor cubed is equivalent to the new volume. And finally, just some formulas that are going to come up that may be helpful. You may want to pause this video in order to write them down, or if you're in my class, it's on page 503 of your textbook. Here's some formulas for surface area and volume, because we may need to calculate the surface areas before applying some particular scale factor. So rectangular prisms, surface area is 2 times length times width plus length times height plus width times height, and the volume is length times width times height. For right triangular prisms, the surface area is base times height plus length times A plus B plus C, and the volume is base times height times length divided by 2. For right cylinders, the surface area is 2 pi r squared plus 2 pi r h, or radius and height for r and h, and the volume is pi r squared h. For right pyramids, the surface area is length squared plus 2 times length times the side length, and the volume is length squared times height divided by 3. And the last two, for a right cone, the surface area is equal to pi r squared plus pi times radius times side length, and the volume is pi times radius squared times height divided by 3. And finally, for a sphere, the surface area is 4 pi r squared. Something got erased here, so sorry, it should be 4 pi r squared. And the volume is 4 pi r cubed divided by 3.